So why do people love video games? Is it the thrilling gameplay, the power fantasy, the opportunity to escape the daily grind and responsibilities? No, we play for the raw joy of scheduling, of punctuality and commitment. But have you made a calendar and day-night cycle in Unity yet? Well, I just did, and I'm here to share it with you. I'm Pollock, student number 101279608. And this is my demonstration of the final assignment for Unity Engine. This time we're making a calendar. So, who's got the time to track the time? Not you, that's who, but I do. Take a tour with me as I show you what I've done. I show you how you can reap the rewards. So, first off, let's see what the players see. So when I launch this demo scene, you can see I've got the player here. They can open up the calendar. They'll show which day they are in, and there's an icon indicating what's special about those days. These first ones have a 50% chance of rain. Down there on the 11th, we've got a sunny day. Here we've got Halloween, and all the way down at the bottom we've got snow, 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 snow into New Year's. And you'll also notice we've got day-night cycling based on the time. Right now I've got this time set to go very, very fast for testing, but that's entirely customizable in the editor. So let's just make it to this sunny day. There you have it. And now let's take a look at what a developer would see while they're working with it. So I've organized everything into this convenient calendar package folder, where you'll find the prefabs used in the scene, and an overworld scene here that you can jump right into, as well as the scripts and the scriptable objects that I've made for those days. The way that a developer would make stuff here is they can jump right in to the calendar canvas. That's where they find the calendar object, which has the calendar script in it. And then they can set stuff like days in a week and weeks in the month. For the time being, then they just set the amount of days total manually by adding them into the editor. The script does support either manually adding them or generating them programmatically. But as a showcase of, you change it to 6 and 5, and you'll see it resizes accordingly. So back to 7 and 4. While they're using it, they can set up any number of special days in the month by adding it to this day list. The day list uses these custom game objects. So we could add this here. We choose what kind of special event we want. So let's add another summer day, and we'll add it just after the first week. And then when I run it here, you'll see it automatically got the t-shirt weather icon as well as all the functionality. And then also, if the developer, while they're working with it, they want to change things like the rate of time passage or which day they start on. So if we want to hurry up and get to that demo day, there we have it. It's 0 indexed for this starting day. That's why it started at 7 to go to 8. It's just more consistent with the logic across the project. And then if they wanted to add new special days, it's from this special event, Scriptable Object. So here in the special days, they can go create special event, and here we have it. So we could say rain or snow day. And then they just select an image to display, so galoshes to keep the rain out. The lighting would probably be sort of purplish on a rainy snow day. We'll give you a 20%, let's say 70% chance of snow, 20% chance of rain. They can also program hours to watch for and a sound to play at those hours. So why don't we say at 2 o'clock, you're going to hear sleigh bells coming. Now, when you jump into the calendar, here we have it in the calendar canvas, calendar. So let's add another event. This one we're going to say it's on, actually here, instead of doing that, just so we can jump quicker into it, let's set the first day to be a rain or snow day. And I'm gonna choose what time we want the sound effect to play. We said 2 o'clock. Oh, we're good. So now that we have that rain or snow day, let's make sure that the time passer starts us on the first day again and run it. This time, there we've got snow, we've got that purple weather, and you heard the sleigh bell effect at 2 o'clock. Yeah. And now that we've showed that for the developer, we're going to take a look under the hood and see how it came together on my end. So we're going to start off at the calendar script, which is the bulkiest one. Some stuff I want to point out is we've got the stuff organized into headers, as you noticed in the calendar, to make it a little more legible for the developer. We've got the calendar details prefabs, which they bind in the calendar dimensions. And then the day list is a serialized list of a custom function called day. This custom function called day just takes in a special event and the date for the special event. And then I'm using the observer pattern here to have the calendar keep track of the days passed, which come from the time passer. And then we set the grid size based on the padding and the amount of days in the month. I set up all the day numbers dynamically instead of binding it out on the prefab. Then I've got the setting current day, which happens every time the listener notices the day past event. So this is where we set the day. We check if it's one of the special days, and if it is, we call the special days day start function, and when that day ends, we call its day end function. And then setting up the special days goes through my list of special days, compares it to the dates on the calendar, and assigns them their image and their and places them in the appropriate spot in the hierarchy. And now looks like a good time to look at that scriptable object. So this is where I set up those data points that the developer can use, like the image, the color it sets it to, the chance of weather effects, the hours to watch for, and the sound effects that trigger at those hours, as well as whether it puts the player into snow. The reason for that is one of the parameters of the assignment had me setting it so that the player hears snow footsteps when they walk in the snow, so I'll have to go there. Let's jump into the time manager. Take me to let's go Christmas Eve, shall we, or Christmas Day. So it used to be footstep sounds, replaced with these sleigh bells. And you know, we're just going to stick around here for a second to show off another instance of the sound effect happening at a time trigger, which is on New Year's at around midnight. Oh, we're going so fast that the sound effect takes a while to kick off. But there you have it, the fireworks sound. And so then we've got these functions for the day start and day end. The day start and day end do the relevant operations, like rolling for a chance of snow, rolling for a chance of rain, setting the daylight color in the day manager. So it's the weather manager and day manager. I've tried to decouple this stuff as much as possible, as well as setting the hours to watch for in the day manager. And the day end basically does that all in reverse to reset the conditions in case the next day is not another event day. And so then we've got that day manager that we kept using these statics for global access to global light, that hours to watch for list, and the sound effects. And again, I'm using the observer design pattern to watch for hour passed in this case instead of day passed, because it checks on these hours to update the light brightness, using some simple math here to find out how far it is away from noon. The further it is, the darker it gets. And then it also checks if the hour that's happening is one of the hours to watch for, and if it is, we can play that sound effect or whatever else the developer wants to add to the project. But that way we can have these events happening over the course of the day. Next up, I want to show that time passer that we keep making use of. And so again, we've got current hours, current minutes, current seconds, current day, and these unity events for hour past and day past. And then where we set up the starting day, and the time display is referenced here because in the UI, as it's running, the time updates. And for this debugging, I've got it takes 10 seconds for a minute and 10 minutes for an hour to speed us through a little more quickly. This is dynamic in the sense that we could go all the way up to 60, 60, and 24. And if we were to set the time scale, which is a serialized thing here, we could go all the way to real time. Start on the first day, start passing time in real time. 1 Mississippi, 2 Mississippi. And it does pass them in hours, minutes, and days. And then it invokes this hour past event and hour days past event, which is, as we said, is watched by the calendar and the day manager. And then we've just got little stuff like this footstep sound, checking for if it's in snow, which is set by those snowy weather special events, scriptable objects. And then that's about it for the big stuff. Finally, we've got this sound effect which plays those sounds. The one shot is bound by the scriptable object. See here, it bounces the sound effect. And so basically, there we have it, a fully functioning system. And it also runs even when the calendar is closed. So time will keep passing, days will keep passing, the rain will keep starting and stopping. You know the business. Okay, so that's for me. Thanks for watching along, and we'll see you later.